Hi everyone, welcome to this next video. So in this one we're going to be looking at histograms and box plots. We're going to just go through the basics of drawing a histogram, then looking at interpreting histograms. We're going to look at then working backwards with histograms, and then the basics of box plots, how we plot them, how we can interpret some information. So let's jump straight in. So we've got here a table that shows the weights of the England rugby team in the Six Nations. We need to draw a histogram to show us information. So the first thing you need to think about is this word here. You need to have frequency, density. Okay, so your key thing to focus on is making the frequency density. Now frequency density, which I'm going to refer to here as FD, the way you find that is you do your frequency and you divide it by the class width. Now what I mean by that is this is my frequency and my class width is the difference between these two values here. Now what you'll notice is that that's a difference of 5 there, that's a difference of 10, that's a difference of 15, that's a difference of 10, difference of 5, difference of 10. So with a histogram you'll notice that the widths of these bars are going to be different, okay, which kind of helps separate it from a bar chart. So if we look at this first one, to find the frequency density here, what we're actually going to be doing is 2 divided by, so that's my frequency, the class width being 5, 2 over 5, and if I think about that as a fraction, it's quite easy to do without a calculator. 2 over 5 becomes 4 over 10, which is 0.4. Next one becomes 6 divided by the difference here now is 10, which is 0.6. Okay, if you want to pause the video and fill in the rest you can, or if not then I'm about to go through them now. Then we've got 18 that we're dividing by the difference here between 95 and 110 is 15. So we're looking at that both divisible by 3, so that becomes 6 over 5, which is the same as 1 and 1/5, so that gives me 1.2. Okay, so 18 divided by 15 gives me 6 over 5, which is 1 1/5. Next one, 10 divided by, well, the difference between 10 and 20 is 10, so that becomes 1. Next one is 2 divided by 5, which again is 0.4, and the last one is 2 divided by 10, which is 0.2. So your first thing you're looking at doing is getting all of your frequency densities in, so that's your key kind of thing that you're going to look to plot with. Okay, so when we're looking at histograms, we use this information here and we don't use the frequency. So if we look down at our graph now, we've got a graph that goes frequency density on the y-axis and weight on the x-axis. We now need to plot this information that we've got. So just remember, you are plotting the bars against the frequency density. So between 80 and 85 goes to 0.4. So between 80 and 85, that is my first bar. The next one, 85 to 95, goes to 0.6. So 85 to 95 goes to 0.6. So that's my bar. So I can tick those two off. Next one is between 95 and 110 and goes to 1.2. So I'm going across there to 110, down there. So that's my next bar. Next one, 110 to 120 is at 1. So I go across here, draw my line down. That one's done. 120 to 125 is at 0.4. So again, not a thinner bar. And the last one, 125 to 135, is at 0.2. So that is my histogram fully completed. Okay, I've got my axes labelled, frequency density, and weight in kilograms. Now, a side note here that what we can look at is if I want to work out how many people are in each bar, I can actually find the frequency from the graph. So a key thing to remember here is if you find the area, so the area of each bar gives you the frequency. Okay, and I'll show you what I mean by that. So this is a really important thing to be aware of, especially when we look at the next question we're going to speak about in a second. So as we can see here, each one of these bars is a rectangle. So the way you find the area of a rectangle is you do the width times the height. Now in this case, the width here is between 80 and 85, so my width is 5, and my height is 0.4. So if you do 5 times 0.4, you end up with an answer of 2. Okay, it's effectively 40% of 5. So that there gives me a total of 2. If I look at the next one, 85 to 95 is a difference of 10, and the height is 0.6. Well, 10 times by 0.6 gives you 6. Same again here, 95 to 110, difference of 15. 15 times 1.2. If you work that out, 15 times 1.2, you get an answer of 18. Okay, so that's a really important point to note. The area of each bar gives you the frequency. Okay, so we'll look at that a little bit later on about how that helps us with some other questions, especially when it comes to working backwards. Okay, so now let's move on to the next part of this. How can we interpret this histogram? What can we do to find the median? So this question is asking me to find the median now. So the median is the middle. Okay, and normally what you would do is you would put all the data in order from smallest to biggest and find the middle value, and then that will be your median. Now in this case, what we have to do is we have to take the total pieces of data. Okay, so total pieces of data, add 1, and then divide it all by 2. That's how you find your median number in terms of which piece of data it is we should be looking for. So if I add all of this data up here, I've got 6 plus 2, which is 8, plus 18 gives me 26, plus 10 is 36, plus 2 plus 2. There's 40 pieces of data. So I go back down here and say there's 40 pieces of data. You add 1, divide it by 2. So you're saying 41 divided by 2, which is 20.5. So what I'm looking for is where is the 20.5 piece of data? So between the 20th piece of data and the 21st piece of data. Well, the first thing we know is that in this first bar, there are 2 pieces of data. In the second bar, there are 6 pieces of data. So at this line here, I've currently got 8 pieces of data. Okay? So at the beginning of here, so at 95 kilograms, I've got a total of 8 pieces of data so far. So what I now need to try and find is another 12 pieces of data, or 12 and a half pieces of data. Well, if we look at this bar here is a total of 18 pieces of data. And now we can start to split this bar into sections. So I'll just zoom in a little bit. I'm going to split this bar into each of these sections. And by doing that, you can say there's 1, 2, 3, 4, 5, 6. So the whole bar is 18 pieces of data, and then I've just split it into 6 sections, which means each one of these little bars here has 3 people in it. Okay, so 3, 6, 9, 12, 15, 18. 18 people, each one split into 3 sections. So if I said I got to this point here, well, if 8 pieces of data was here, that's 11 pieces of data. This would be 14 pieces of data. At this point here, that's 17 pieces of data. And at this point here, I'm on 20 pieces of data. Okay. Now, remember what we're trying to find. We're trying to find between 20 and 21. This point here would be 23, so that's way too high. So therefore, if I went in the middle, that point there would be at 21 and a half pieces of data. So therefore, I'm looking that my answer is going to be somewhere between this point and this point here. Now, this is an estimate. So we could say my line, if I was to draw a straight line down, my line would approximately be there at 20 and a half pieces of data. And then what you're looking for is what value does that represent? Well, if that's 105 and that's 110, that'd be 107.5. That's 105. I'd say your answer would be somewhere in and around 106. So the median weight for the team would therefore be 106 kilograms. Okay, and if we go up here and we look at that, looking at the median weight, it makes sense that the 20 to 21st piece of data fits in this group between 95 and 110, but we're saying it's 106. So that's how you can use a histogram to find the median value if you're asked to find that. Okay, let's look at this next example here now, where what we're actually having to do is we're having to use a histogram to work out the table, and we have to use the table to find missing information from the histogram. So in this table here, we've got the weights of 30 dogs that came to a vet's in one day, and I've basically been given one piece of information in the table. Okay, the thing that's missing here is frequency density. Okay, so I'm going to add that on first of all. And remember, that's the key thing for a histogram. So I can find frequency density here by doing 2 divided by the class width there, which is 10. Remember, it's frequency divided by class width. 2 divided by 10 is 0.2. Which means I can now create my own scale on this y-axis, because that's the thing that's missing. I don't know any information about this histogram really, because there's no scale. But now I've just used the information I've been given here to find the scale. So that's 0.2, which means that would be 0.4, 0.6, 0.8. That's 1, 1.2, and 1.3 would be the top of the scale there if we needed it. So by using the table, you can then use information here. And now what we can start to do is fill in the missing information from the table based on the fact that if we go back up here, the area of each bar will give you the frequency. So let's fill in the missing information we've got, or let's fill in what we know. So I can say here, for the second bar, which is between 10 and 15, my frequency density is 0.6. The next bar is 1. I'm missing the middle information here on that penultimate one, and the last bar goes up to 0.3. So they're my frequency density. So we're now working backwards, and all I'm going to do is I'm going to find the area of each bar. So in this one, the width here is 5, so I'm doing 5 times by the height, which is 0.6. So you're doing 5 times by 0.6, and that will give you the area. And remember what we said. If we do if we find the area of the bar, it gives us the total frequency. So there are actually 3 dogs in that bar. The next one has a difference of 10, and 1 is the height. So 10 times 1 is 10. So therefore 15 to 25 is a frequency of 10. I'm missing the next one, so I can't work anything out there. And then the last one, again, 40 to 50 is a difference of 10. And the height is 0.3. So times 0.3 is 3. Now, how can I find this information for the last one? It's really important that you read the question fully. The information is about 30 dogs. Well, there's 2 dogs there, 3 dogs there, 10 dogs there, and 3 dogs there. So in total, I've got 18 dogs. Okay, so 3 plus 2 is 5, plus your 3 is 8, plus 10, 18. Which means I now know that this frequency must be 12, because there has to be 30 dogs in total. And now I follow the process as normal. 12 divided by 15, this is because it's from 25 to 40. So 12 divided by 15. Obviously, if you've got a calculator, you could do 12 divided by 15 and get you 0.8. If you didn't, you could divide both of those by 3, which gives you 4 over 5, which is 0.8 as well. And therefore 0.8 would be my frequency density that I need to plot, and I now can complete that bar, that histogram bar there. So sometimes you will get bar where a histogram question where you're given the bar. So sometimes you will get the bar given to you, sometimes you'll get the table given to you, and sometimes it's a mixture of the two. Okay, so that's the first bit done. We've completed the histogram, we've filled in the table. It says, what percentage of dogs are over 35 kilograms? Okay, so now let's look at how we can use the table and the bar chart to work together to answer this. So over 35 kilograms means I'm looking at this point here. This is my line at 35. Well, I know there are 3 dogs there, okay, because that was 10 wide, 0.3 up, so it gives me 3. Also, I've got my frequency filled in there. What I now need to do is I now need to work out how many dogs are actually in this section here, right? Now, what I do know is that all of this together is 12 dogs. Therefore, if I start to split this into sections like I did in the previous one, I know that that's 3 even bars I've just created, which means there has to be 4 dogs in each bar. Therefore, at this point here to here, there's 3 dogs there, 4 dogs there, so that's a total of 7 dogs, which are over 35. And because it's asking me for a percentage, it's 7 out of, there are 40 dogs in total, remember? So you're doing 7 over 40. So using your calculator, you can work this out. And then because it's asking me to do it as a percentage, I can do 7 over 40 times by 100, which gives you 17.5%. Okay, so if you're asked to work out a percentage, find the line. So I went to 35 there, and then figure out how many are in each bar, or separate your bar into sections to help you. It then says estimate the median. So let's go back to the question we did at the start. How can we use this information to find the median? Well, again, there are 30 dogs in this one. So we're going 30 plus 1, which is 31, which is 30 plus 1 divided by 2, which is 31 divided by 2, which gives me 15.5. So what I need to do is try and find where the 15.5 piece of data is. I know in the first bar there are 2, in the second bar there are 3, so at total I'm at 5 here. Then if I go to the next bar, let's just rub this out. If I go to the next bar, there were 10 dogs in this, so I'm at 5 there plus 10, which means there's 15 dogs here, and I need 15.5. I know that this next bar was 4 dogs, wasn't it? Which means if I split that again in half, I can say that there's 2 there, 2 there, 2 there, 2 there, 2 there, 2 there. If I'm at 15, get to there, that's on 17. So the 17th dog would be there. In the middle would be my 16th dog. And I'm looking for the 15.5. So therefore, I'm looking for the middle between that purple line and that red line, which would be here. Now, we look at the scale. That's 25. That's 30, so that would be 27.5. We're looking, that's probably around about 25.5. If we break it down into each section, it says estimate, so we can have a range of answers. So what we can say is the median weight, for the dogs here is 25.5. And what I've done is gone to the 15.5 piece of information there. It's just over 25 and probably just below 26. Okay, so that's your histograms, working forwards, working backwards, finding medians, finding percentages. Make sure you're happy with all that information. So the next thing we can look at now is box plots. Okay, so the following data shows the ages of 20 teachers at a school. We've got a lowest age of 22, a maximum age of 52. We've been given the lower quartile, upper quartile, and median. Now, really important, there are varying ways you'll be given this information. You could be given the lower quartile, for example, and then told what the interquartile range is. Now, the interquartile range, which is your IQR, interquartile range is the difference between the lower quartile and the upper quartile. Okay, so lower quartile and upper quartile. So in this case, the difference between 28 and 45, so that would be 17, is my interquartile range. So they may give you the lower quartile and then say the interquartile range is 17 and you have to find the upper quartile, or they may give you the upper quartile and say the interquartile range is 17 and you have to subtract it. So just make sure you're happy with that concept, that the interquartile range is the difference between the lower and the upper. So to plot this as a box plot, all you do is you go to 22. Let's quickly check what the scale is here. That's 20, 22, 24, 26, 28, 30. So each one of these represents 2. So I go to 22 and I draw a bigger bar, a bigger line. That's my lowest age. My maximum age is 52. So I do the same thing, making sure those 2 bars are the same width. I'm going to go to the median at 32. Draw my line there. 28, which is that one. And 45 that you need to plot. So 42, 44, 45 is the middle here. So now you've plotted all those key points, you need to then draw a box around your lower quartile to your upper quartile. And that represents, the length of that box represents your interquartile range basically. And then you need to join from your upper quartile to your end value, from your lower quartile to your end value as well. So that's your box plot drawn. So now we need to start to understand what each value represents. Well, this line here is your median. So what that means is 50% of the data falls between here and here, and 50% of the data falls between here and here. So therefore you could say there's 10 pieces of data here. So there's 10 teachers that fit between here and here. And then there's also 10 teachers that fit between here and here, because there's 20 in total. Half the data would be below the median, half the data would be above the median. And then you can also start thinking about the fact that this line here is your upper quartile, which is the upper 25%. So that's 75% of the data, meaning that there are 5 teachers here. So because that's a quarter of the data. And then you can also say that between this point here and this point here, there are 5 teachers as well. So we can say that 5 teachers are less than 28 years old. We can say that 5 teachers are greater than 45. And therefore we could also say that this box, there are 10 pieces of data that fit in this box, because 50% of the data from 25 to 75 fits in there. Okay, so that's how you can use your interquartile range. You can use your upper quartile, your lower quartile to estimate how many teachers fit in each piece of data. So what happens now if you're being asked to plot a box plot that you're not given the data in a table like this, but you're given the raw data? So let's look at this. Now, the lower quartile, the lowest value and the highest value are easy to plot. So we can go to 22, and I can plot my line there at 22, and I can plot my line there at 50. That's pretty simple. Now what you need to do is you need to find the median, we need to find the lower quartile, and we need to find the upper quartile. So median, the number of pieces of data, we add 1 and we divide by 2. There's 19 pieces of data plus 1 divided by 2 means I've got to get to the 10th piece of data. This is the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th. That is your 10th piece of data, meaning that that is your median. So 33 is your median value. Okay. Now we need to find the lower quartile. Well, the lower quartile is exactly the same. So it's pieces of data, add 1, but this time you divide by 4 because it's a quarter. So we're doing 19 plus 1 divided by 4, which is 20 divided by 4, which is 5. So we're going for the 5th piece of data, which in this case is 25. So I go to 25, so that's 20, 22, 24, 25 is there. I then need to do the final one, which is the upper quartile. So again, you're going pieces of data plus 1 divided by 4, but this time, because we're upper quartile, we times that by 3 because that's the 75% mark. So you're basically saying 5 times 3, which is 15. So we're looking for the 15th piece of data. That's 11, 12, 13, 14, 15. So 38, which is here, is my upper quartile. Then I do the same process as I did before. I join the upper and lower quartile together. I join the upper quartile to the highest value, and I join the lowest value to the lower quartile. And you can see there that the box plots are very different to each other. So the question then says for us to compare the distribution of the two schools. So I'm going to just delete this information here so I've got some space. When we're comparing the distribution, I'm going to call this school A and this school B. So I'm going to compare two things. I'm going to compare the median, and then I'm going to compare the interquartile range or the actual range. It doesn't matter which one you choose to do, but you need to make sure you compare one of those. Now let's look at the medians first of all. The median in school A was at 32. Okay, that's my median there. And the median at school B is at 33. So we can therefore make a statement that says the median age, so the median age at school B is higher than school A. Okay, so you're saying that it's higher or lower, because it's asking you to compare. You've got to say one is higher than the other, or the other is lower than the other one. So you could say school A has a lower median age of 32, whereas school B has a higher median age of 33. Now the next thing I'm going to look at is this interquartile range. So the interquartile range is the difference between the lower quartile and the upper quartile. So in the first one here, our interquartile range is between 28 and 45, which we said was a difference of 17. So your interquartile range in school A is 17, whereas your interquartile range in school B is actually 13, because that's from 25 up to 38. So we can therefore say the interquartile range at school B is lower than school A. What that means is more of the data is closer together. If your interquartile range is really wide, it means that 50% of your data is spread out. If your interquartile range is lower, it means that your data is closer together. The final thing you could compare is your overall range. If we look at school A, our lowest stage was 22, our highest stage was 52, so we can therefore say that our range is 30. And if we look at school B, our lowest stage was 22, our highest stage was 50, so the difference between 50 and 22 is a difference of 28. So although the data is still close together, we can say that school B has a lower range at 28 compared to school A, which is higher at 30. You don't have to necessarily mention the numbers exactly, but what you're basically saying is one is higher or lower than the other one, and in this case school B being a lower range, which means again the data is closer together. So the interquartile range is closer together and the overall range is closer together, so it means most of the data is closer together than in school A. So that's all our information about histograms and box plots. I hope you found it useful, hope it helps you, and I will see you all in the next video.